Hi everybody.
Okay, so now we'll all mute ourselves. हम सब अपने आप को म्यूट कर लें क्योंकि कौशिक अंकल को फिर हम ठीक से नहीं सुन पाएंगे. Thank you.
Hi. Hi everybody. I'm Kaushik here. So, can you tell me your ages roughly? Like, you are from that 7 years, 10 years?
7 years.
8 years.
Okay. So, are you familiar with
10 years.
astronomy kind of things? Astronomy, astrology? Have you heard of these terms?
Yes.
Yes.
Okay, good.
Yes.
Okay, before we start, let me tell you who am I. Okay, so I am and my name is Kaushik, and I'm basically an electronics engineer, and I run my own company which manufactures electronics stuff for people, and I have few hobbies which I normally follow. And few of the hobbies, I'll give you a list of my hobbies because there are many hobbies which I used to have when I was a kid like you. But right now I have come down to few hobbies, which are one of them is photography. Second is astronomy. Third is like swimming, hiking, trekking. Okay, all adventure stuff. Okay, and right now because we are in lockdown, we have things which we need to do at home. So we do a lot of do-it-yourself stuff, okay? Like creation of games, toys, or maybe some decorative stuff. You can do all those stuff when you are in lockdown, when you cannot go out. Okay, these things can be done. So we normally practice that kind of stuff out at home. Okay, so before we start, let me show you few things which is lying in my background. These are the telescopes which I have. Okay, this is the big one and this is a small one. Okay, so this small telescope is uh, which I used to use. Nowadays also we use it for observation. And the big one which I have here is normally used for photographic purpose. Okay, so but today we are not going to cover telescopes as such initially, but I'll give some introduction on that later on. But right now we'll start with the basics of astronomy. So should we start? Okay.
Yes.
Okay, just a moment. I'll just start the presentation.
Kaushik uncle, sorry, can you just help me become the co-host, please?
Oh, sorry, I forgot that.
No worries.
Yeah.
Yes, thank you.
Right. Okay. Okay. Uh, so, are you able to see the screen?
Yes.
Yes. Okay. So let's start with the beginning. So this is the first slide. So let's start with the beginning. Okay. So what we are going to do in this session is these are the topics for the session. if you have got any doubt, uh,
हम प्लीज म्यूट कर लें अपने म्यूट करना पड़ेगा. आई वुड प्रेफर आप लोग सब अपने आप को म्यूट कर लें इस वक्त, एक्सेप्ट कौशिक अंकल. थैंक यू.
yeah. So let's see the topics for the session today. The first is what is astronomy. We'll be discussing that in point wise so that we can go through the session smoothly. So first point is what is astronomy. Second will be like why astronomy. I'll be talking a little bit of history, not much. I know history is boring, but still a little history. Okay. Then what do you mean by amateur and professional? What is the difference between amateur astronomy and professional astronomy? Okay. Then where and how do I start? Like how do you start doing this astronomy thing? Okay. How do you learn it? Where do you start it? Okay. Then we'll start with the basics of the whole thing. Okay. And then some tools which you can actually use to learn astronomy, because we cannot go out right now. We have this crisis of this coronavirus. So I'll show you a single tool initially, which is the easiest tool, okay, which you can use for your basic learning tool, I can say, okay, without even going out of your room. That is the best part of it, okay. And if you have your terrace,
Yeah.
like if you're in a building where you can access your terrace, you can go to the terrace and try to find the stars, or you know, correlate the things what you learned today, and maybe it will help you to understand this
Hmm.
better. Okay.
Yeah. Yeah.
Okay. We'll have question answer sessions in between also. So if you have any questions right now,
Hmm.
just note it down in a piece of paper, and when we have the question answer session, you can just ask me the questions. I'll try to answer you as far as possible in simple words. Okay, fine. So let's go as usual. Like we have a uh, definition. uh, Ashita, there is somebody in waiting room.
Yeah, I have allowed. No
Okay.
worries. Yes.
Yeah, something.
Again, astronomy.
So actually, what is astronomy? So there is a definition of astronomy. The astronomy is a study of sun, moon, stars, planets, comets, galaxies, gas, dust, and other non-earthly bodies, and the phenomena what happens among themselves. Like for example, Earth is moving around the sun. That's a phenomena. Okay, the moon is revolving around the Earth, isn't it? So that's a phenomenon. So these kind of things which are not only Earth, okay, outside Earth, whatever happens outside Earth, okay, and when we can observe those things in through our uh, telescopes, through our naked eyes, okay, or using a binoculars, anything. So these kind of things which are like non-earthly bodies, okay, apart from Earth, anything outside Earth. For example, like the moon, it's not an earthly body, it's a celestial body. Okay. So all these things, they are part of astronomy. Okay. So how did it start, and when it started, why people started looking into the sky and all these things? There's a little bit of history. So we'll go, just go to the next slide. Yeah. Somebody raised hand. Yug. Hello.
Yeah, no worries, Kaushik. You can carry on. We can have the questions later.
Okay, okay, fine,
Yeah,
fine.
yeah, no problem.
Yeah, yeah. Okay. So definition of astronomy is somewhat like that. So we'll go to the next slide. Like why astronomy? Why people started doing astronomy? What is this thing called astronomy, and how people started this? First of all, we are human being, and we are very curious beings, you know. So we just love to learn things. Okay, we are very curious. Like you must have seen cats or dogs. They are also very curious about things. When you get a new thing in your home or new toy or something, you do some, if you're even if you're shifting things here and there, your pet will always, you know, be along with you. Like we have two cats, we know that, because they are very curious. Similarly, we humans are also very curious about things, like why this day and night happens. Okay, you must have learned this kind of things in your geography lessons or in your science lessons. Okay, so basically, we are curious. So we have a curiosity which cannot be, you know, you can say it is cannot be fulfilled, uh, with anything. We have never ending curiosity. If I achieve something, then I go for the next thing. If I achieve the next thing, then I go for the third thing. So we keep on moving ahead and ahead because of this curiosity. Like I can tell you, like 30 years back, there was no cell phones. Okay, right now we are using cell phones and tabs and internet connections and whatnot. Okay, so 30 years back or even 20 years back, these things were not possible. Okay, we had cell phones 20 years back, but these internet and all these Zoom sessions or anything like that was not possible. Okay, because of human curiosity, we moved forward, and we do things like that. So similarly, astronomy was also like, because of a human curiosity, people started asking questions. See, initially when people started, they started with fear. Okay, for example, what they feared about, you know, when the early nomadic tribes were there, or you can say the early humans. Okay, the, these people, they could not understand a thing about Earth's, you know, happenings. For example, rain. Okay, they could not understand how this rain happened. They could not understand lightning. They could not understand fire. Why this fire happens in the mountains, or why this lightning happens in the mountains, or when the lightning strikes the mountain, the mountain starts, you know, catches fire. So why these things happen? So people never knew about those things. So this is how curiosity came. First of all, it was fear. They thought that some external force,
Yes.
okay, some external force, like today we call that force as God. Okay, they didn't even know at that time what God was. Okay, God is also made by humans, for in that terms actually, because the God was born because of human fear. Okay, because we are afraid. Okay, we thought there is some force, there is somebody who is trying to, who is very angry on us. That's why that person is doing some lot of lightning or earthquake or rain or something like that. That's why that's what people thought about initially. But slowly they could understand a little bit. They thought, okay, if the God is angry, then we should actually give some offerings to God. Okay, for example, they started throwing food, basically food, to that fire, or that towards that lightning. When the lightning strikes, then people used to throw food. Okay, they thought that at least the lightning will be happy once they have food. Okay, then they saw fire. Because of lightning, the fire used to occur on the mountains. So they started offering food again to the mountain. Okay, so this process of, offerings and getting frightened by at the initial stage, they led to something slowly when they started, okay, this food is not helping it, they started with the food, but the lightning still continued. Nothing happened. So when that happened, they thought there must be something else. We should understand, right? So what is that something else? Okay. So they tried to understand uh, why this lightning is happening. Okay, they have to. They said, okay, let us figure out why lightning is happening. So some few thousand years later, they came to know why lightning happened. Okay, so if you search for lightning, you'll come to know a little bit of history about that way. Okay, so I don't have to explain all this stuff to you because Google is already there for you. Okay, I don't want to get into again teaching you science, geography, and all those things. So better Google, and you can start with that. Like next point, we'll go for that. Like when it started, we can say roughly about this date. This is a year actually, 3114 BC or BCE, before Christ, as we say. Okay, so if it is 3000 years back uh, before Christ, and now it is 2000. Okay, so it is about 5000 years back the astronomy started. Okay, so and what people started understanding the moon cycle.
One second.
Moon cycle discovered and by the Mayan astronomers. The Mayan astronomers are from China. Okay, initially they started with the the moon cycle. Then Indians, the Greek, the Islamic civilizations, everybody started contributing into your astronomy. They started looking into the sky and started understanding the patterns of the stars, okay, the moon cycles, the seasons of Earth, the rotation, revolution, okay, of Earth, and all these things. Okay, slowly they started understanding these features which happen, these events that happen. For example, there was an eclipse recently. If you I had actually posted in Tribe uh, a solar eclipse. Before that, 15 days back, there was a lunar eclipse. Normally, eclipses come in pairs, lunar plus solar. But uh, yeah, sometimes you can observe them. Sometimes we may not able to see them because it is on the other side of the world or some other part of the globe. So we may not able to see it. But most of the time, if you're lucky enough, you can see one of those eclipses. And those things were discovered by uh, those early astronomers, like Mayan, Indian, Greek, and Islamic civilizations. They contributed to those things, and then they noted down how eclipses occur, when they are occurring. They calculated the values and timings towards the eclipse. Okay, so all these things have been has evolved over over thousands of years, like 5000 years now, 5000 plus years, you can say. Almost it is 5000, let's say 250 years or 200 years now approximately. So slowly these things evolved in this 5000 years, and today we are having the latest technology. What we have is we have space telescopes, and like Hubble Space Telescope, you might be knowing one. Then we have International Space Station. Then we have many other Spitzer. Okay, then Curiosity rovers. Okay, many things we have been mankind has done to understand. Okay, and lot many things about the neighboring planets, our solar system, our galaxy, and the universe. Okay, so this is all because of only one question. Okay, that question is this one. Okay, that question says that, are we alone? This started the passion for astronomy. Okay, so many people started questioning this, that are we the only planet which is having human beings, or there are more such planets which there will be other human beings which we call aliens. As you know, yes, you might have seen some alien movies. Okay, so that's what, like, so we we humans are very curious about it, so we started a organization called as SETI, SETI. The full form is given, the Search for Extraterrestrial Intelligence. Okay, extraterrestrial means out of Earth. So we started trying to see the sky, trying to search in the sky whether are we alone, or are we getting some alien signals from different planets maybe, or from a different galaxy maybe. Okay, so we started searching, and the search is still on. Okay, so this SETI organization, I have given the link also. If you want, if you can check it out. There are a lot of details about this organization in that website. Plus, you just Google for SETI, you will get a lot of things which you will have. Uh, uh, and that's the second question, which is there's a big question, is the how universe works. This is tremendously big question. Still, we don't have a lot of answers. Okay, what happens inside the sun? Why it is so hot? Okay, how the sun is working? Okay, so yeah, we know a few things now. There is a nuclear fusion going inside the sun. Okay, yes, we know that kind of things, but still we don't know many things which are unanswered. Whether the universe is expanding, whether it is contracting, or how the galaxies are formed, what are black holes, how these comets are formed, why there are some extraterrestrial bodies coming into the system, into the solar system, external to the solar system. Many things are there. Okay, so as and when we go, and such kind of questions are there, and tons of questions people ask themselves and try to find the answers. Okay, so this is how the astronomy has happened, and that's why astronomy is. Okay, so astronomy is a pure, curiosity based or curiosity driven science. Okay, yeah, it has got a lot of it has evolved from 5,000 years plus now. So it has come up with lot many mathematical calculations, lot many theories, lot many uh, beliefs, you can say, or lot many crazy answers, rather, I'd say, uh, which kind of hard to digest for people like us or you and me, because we are not astronomers. We are not pure astronomers. Even I am not a pure astronomer. As I have told you in the beginning, I am an electronics engineer. Okay, astronomy is my hobby. Okay, so we are not pure astronomers. So there are people who are actually pure astronomers. I'll come to that point again. Okay, so because of these questions, we have started understanding astronomy a little bit. Okay, so we'll go to the next slide. And in this slide, I'm going to explain what is the difference between people like me or people like you who are trying to understand what is astronomy, and versus the professional astronomers. Okay. So what is amateur astronomy and professional astronomy? Okay. So basically there are basic clean, there's a very clean differences. So I'll just explain the differences between the amateur and professional. And we are all going to become, or trying to become, amateur astronomers. Okay, you start astronomy with amateur, and then slowly you progress to professional astronomy. Okay, if you find it very interesting, you slowly from amateur, you start from your this age. This is very nice age that you can start. I started pretty late. I think I started when I was about maybe 15, 16 years old. Okay, but you are starting even earlier, it is even better. Okay, so let's try to understand what is amateur astronomy. So amateur astronomy is a hobby, basically, where the participants, like people like to enjoy the sky, observing or imaging. For example, you want to photograph the moon. Yes, you can do that. Okay. So people, people can just, uh, photograph the people might want to see the moon. Okay. Once we see the moon every day, but when you see the moon through a telescope or through a pair of binoculars, even a small telescope, you'll be simply fascinated. You'll be wowed by the moon itself. Even when I first saw the moon through a telescope, I was I was mesmerized. It was beautiful. It was a beautiful sight that I never saw the moon as beautiful as before that day. I used to see the moon through normal eyes, I didn't have a telescope. The first time I saw a telescope and I saw the moon, it was amazing. Okay. So someday maybe I'll try to get, when we are able to come together, I might organize a session for moon, seeing the celestial bodies through a telescope or something. Okay, let's hope for that. I hope this pandemic goes very soon. Okay, and we can have a session like that. Okay, but right now it is not possible for two reasons. One is for the virus, and second is now the season is off because we are having rainy season. We have a lot of clouds around. So the season normally in Mumbai starts by, you can say, the month of December onwards. December, Jan, Feb, March, till April. Yeah. So around 4 to 5 months, maybe November also may be included. Yeah. So we can do that. Right. And then we have uh, basically we first, before going into telescopes and all this stuff, uh, we have to understand some basic things which, without anything, without any instrumentation, without any tools. For example, there is no telescopes, no binoculars. Okay, just by your eyes. Okay, just by your eyes, you can still enjoy the sky. Okay, I'll teach you later on. I'll give you a demonstration how to do that. Okay, and how you can locate things in the sky. Because if you look into the sky just like that, you'll never know what you're looking at. So I'll show you. Okay. So next point is what amateurs don't do. Okay. Amateurs do not use the field of astronomy as the primary source of income or support. Okay. We don't earn from, we are amateur astronomers. So we don't earn from our hobby. It's a hobby. Okay. So it is not, it is not our support system. We don't earn from the astronomical thing. Yeah. For example, if I'm working, if I'm doing some job, I'm earning, isn't it? But if I it's my hobby, let's say I'm listening to music, it's my hobby. Yeah, I'm not earning from it. Okay, so amateur astronomy is also just like that. Amateur astronomy does not, astronomers don't earn from their hobby because it's a hobby. Okay, and usually they don't have a professional degree. Yes, I don't have a professional degree on astronomy, but because over right now you can say uh, it's almost like maybe 25 to 30 years now I have been uh, after this astronomical stuff. Okay, so that's why I can give you some presentation. I can teach uh, some of you how it can be done, how it is how it can be uh, uh, how it can be started. That's how what I can teach you right now. But yes, uh, we have other things also, like uh, there are degrees which comes along with astronomy. There are like astrophysics. Okay, there are cosmology. Okay, these kind of things are also there which you can learn. But right now we are not learning those things. We are trying to become we are trying to learn the basics. Okay, we are trying to become the amateur astronomers. Okay. uh, Soon I'll take a break after one more slide. Okay. uh, then we'll have a small Q&A. Fine. So the definition goes like this, okay, as it is in the screen. An amateur or is a scientist, and an astronomer is a scientist in the field of astronomy who studies focuses on the studies on specific question of field outside the scope of Earth. So means what? For example, a particular scientist will try to understand the let's say the scientist is studying Saturn, one of our planets. Okay, some scientist is trying to study Jupiter. Someone is trying to study Mars. Someone is trying to study the sun. Okay, so a scientist will, astronomer or a scientist, which is going to do only one particular job. The person is not going to go into many different things at the same time. Okay, so that is what an astronomer or professional scientist is. Basically, it is like they're very focused. They're very their focus is at a very small area. Okay, but they usually fall under two main categories. Okay, so one is observational scientists. Okay, which they observe things with using their telescopes and other professional tools. Okay, and there are some theoretical scientists. They are you can say they actually do calculations, they do the mathematics, and they try to understand the universe by the theories. Okay, like Einstein did. Okay, he was more of a theoretical scientist rather than an observational one. Okay, his theories are still being proven by a lot of other scientists in today's day. It's amazing. Okay. But there are observational scientists. For example, Galileo was an observational scientist. Okay, so he used to do that. Hubble, okay, he was a observational scientist. Okay, there are many observational scientists. Okay, so there are two basic categories for these scientists. And observational astronomers, they use the observatories for celestial objects like big telescopes and things like that. Okay, like there is one Keck telescope which they use. Okay, which is a huge telescope. Okay, then they are coming up with a 30-meter telescope. Yes, then there is this Hubble telescope which is out there in the space. These things are used by observational astronomers. Okay. And theoretical astronomers, they have these models, mathematical models of things that cannot be observed, which cannot be seen directly. Okay, which is pretty complex to understand right now. I won't go much into that part. Okay, there are things like dark matter, uh, and things which happen. Okay, so that's it about the amateur versus professional. Okay, so yeah, this is a quick break. So you can ask me questions if you want.
Anybody wants to ask any questions right now?
I'm Mitali. I wanted to ask a question.
Sure.
What is a moon cycle?
A moon cycle. Okay, a moon cycle is you can say the 28 days cycle. As a moon takes 28 roughly about 28 days to go around Earth, right? So
Yes.
that's the moon cycle. Typical cycle of moon. Like we have a Earth cycle which takes roughly about 365 days to go around the sun.
Yeah.
So a cycle means circle. Okay. You have bicycle, right? You know about bicycles, right? Why it
Yes.
is known as bicycle? Bi means two. A cycle means circle. So there are two wheels which are two circles. That's why it is bicycle. Like a cycle is a complete circle. So moon takes roughly about 28 days to go around the Earth. So it is known as a moon cycle.
Thank you. Thank you. Sir, I have a question.
Yes, tell me.
How does a star look?
A star looks like a dot, nothing else. Have you seen the sky ever?
No,
Never?
no.
You have never looked to the sky. Today you do that. Today in the night, you just look up into the sky, you will see the stars. Do you know the rhyme Twinkle Twinkle Little Star?
Yes.
You know, you have sung that, right?
Yes.
Yeah, yeah. But have you seen the star exactly? It twinkles, it blinks.
No.
Do it tonight also. When it gets dark, I say about 8 o'clock, 9 o'clock, you just look up above into the sky. You will see the twinkling stars, right?
But at 9 o'clock I sleep.
Yes, yes.
Can I ask a question?
Yes, please.
What actually is the sky? Like, do we look at the same piece of the universe every day, or does it change as the Earth rotates around the sun?
Yeah, actually, everything in the sky is moving. Everything, like every object in the universe is moving.
Okay,
But the thing is that they're so far away. Like for example, I'll give you a simple example. For example, if you're driving in a car, you are moving on the road, you will see the trees or anything which is passing by very fast, isn't it?
correct.
But when you see something further, like a mountain, it seems that the mountain is moving very slow.
Right.
Yeah, but we are moving at the same speed. Like if you are moving at 60 kilometers per hour, we are actually moving at 60 kilometers per hour. But it's a relative speed which we are seeing is yeah, we have lost the power right now, so maybe the lighting has changed a little bit, but we are continuing, no issues. So we are moving at 60 kilometers per hour. Then something which is very close by will cross us at 60 kilometers per hour. But when you see a mountain far away, that mountain seems to move slower. And if you see the moon at the same time, you'll feel that moon is actually moving along with us. It is
Correct.
not going behind. So this is what is known as a relative motion. And stars are so far away that in our lifetime, or many thousands of years, uh, the star will seem to be in the same place forever. Actually, stars are
Okay.
like our sun is also moving, and along with the sun, the entire solar system is also moving around. Okay, but we don't feel it because we are in this tiny planet called Earth, and we don't move. We are moving along with the solar system, which is so huge that we just can't. It takes about 35 years to reach the edge of solar system, even if you're going at a very high speed.
Okay.
Yeah. Hope
So
I
what is a
So,
black hole?
pardon.
So a black hole.
A black hole. It's a huge subject in its own, actually. Uh, but
Sir, what is a Big Bang?
just a minute. I'll come to that.
Sir, it is a star which it died and it's a comet. It is sucking everything from everywhere near to it due to gravity.
Uh, yeah, I'll first answer that black hole question. Actually it's a very simple thing. Black hole is an object not to be seen, because that's why it is known as a black hole, because
Yeah.
uh, it has got such amount of gravity that even light cannot escape its gravitational force. Even light has been pulled inside it. Okay, so it is known as a black hole. It's still under lot of research what a black hole is. Okay, and even we are not very clear exactly how a black hole exactly looks, because we cannot see them. There's no light is coming out from it. So the black hole remains as a black hole. It's known as a black hole because nothing comes in. So we see a black portion, a sky which is just having a black area. So it's just a black hole. There are a lot of things, a lot of research is going on how a black hole might look like. So theoretical physicists or theoretical, uh, as I've told you, this professionals, they are trying to model a black hole and they're trying to calculate how might a black hole look. Okay, which is pretty difficult task to do because kind of complex mathematical stuff is involved. Yeah.
So what is a comet?
Comet is a extraterrestrial object which normally comes from the edge of the solar system. Okay. If you just Google for what is a comet, you'll get a very nice write-up on Wikipedia, which will explain you exactly where it comes from, because there is something known as a belt. Okay, the orb. Okay, there's a orb around the solar system. Okay, there are a lot of icy objects out there, which are sometimes getting attracted towards the sun. So comet is like you can say it's like a small object which is formed with iceous metals, like a lot of water, lot of minerals inside it, like lot of gas, lot of solid stuff like iron, potassium, magnesium. These kind of metals are also there. Okay, so all these things are being pulled towards the sun, and when it comes towards the sun, because of the heat, okay, the you see a tail which goes away from the sun because the heat, this gas and all these vapors, they come out of the rock, and that rocky surface becomes the head, and there's a long tail which looks like a like a long parachute like thing which is moving towards the sun, like you can imagine a teardrop shaped kind of a thing. Okay, where you can see the object. If you hang a teardrop like this, so it is upside down teardrop, and that's how it looks typically. I'll show you a photograph if I can.
तन्मय, आपको कुछ बोलना था, कुछ पूछना है आपको?
हाँ.
पूछो पूछो.
Does star have surface?
Stars do have a surface, yes. Sun has a surface. They have a surface. But the problem is that you cannot stand on that surface. It's very hot. Okay. It's so hot that you will become vapor.
Sir, I have heard that the sun's surface is more than 6,000 degrees hot.
Exactly, exactly. The sun's surface is very hot. That's about 6,000. You heard it right.
And sir, I think there are more hotter stars than sun.
Yeah, actually, sun itself is very hot inside.
Yeah, but like I mean, there are more. I think.
Yeah, there are different kind of stars.
Yeah, hotter.
Stars which can become very hot and can
There
explode.
used to be red giant.
Red giant, yeah, Betelgeuse is a red giant. Red giants are like they have expired their fuel and they become red. If you can imagine, you can visualize this. If you take an iron and put it in fire, it turns red. Okay, so a red giant is similar. Okay, what happens is if you heat the iron even more, it will become yellow, and if you heat the iron even more, it will become white. So more the heat, whiter it becomes, and lesser the heat, redder it becomes. Okay, so a red giant is like it has lost its it has used up its fuel, and slowly it is getting cooler. That's why it has become a red giant. And also it loses its gravity, so it becomes bigger and bigger and bigger.
Sir, does a star have a life?
Yeah, they all do. Just like us, stars also have their.
After the red giant expands and it goes uh, above its limits, it will become small and will become into a white dwarf.
Yeah, they have got two things. They have become white dwarfs. They become quasars. They become neutron stars. There are many stars. If you see a life cycle of a star, it depends on the size of the star, the amount of material inside the star, and what it should become after it dies. Okay? So it can become a white dwarf, quasar, a neutron star. It can simply explode into gas and become again a star again. Okay, so there are many things can happen on that. Okay, so we'll have another session just later on this. Okay, we'll continue with the slideshow there because there are a lot of slides pending. Okay, so, okay, everybody fine?
Yes, sir.
Can I ask a question?
Uh, can you just skip it for now? In the next,
Okay, later.
okay. So next slide is where do I start and when, right? Just a minute. Okay, okay. Where do I start? We can start right now. Actually, unfortunately, it is sun is still up. You cannot see any stars right now, but here we can start the session today itself so that you come to know the basics, the fundamentals. Okay, so first we have to know some basic knowledge. Just a moment. Some basic knowledge so that we can get into the journey of becoming an amateur astronomer. Okay, so yes, we are going to become amateur astronomers. So let's learn the basics. The first thing is to know is the directions. Okay, so let's understand the directions. How do you find directions and how do you do this thing? Okay, to find out directions. What has to be done? How do you know where is east, where is west? Okay, so how do you find the direction? There is a few tricks. Okay, I'll be giving you only one or two tricks right now. There are many others. Okay, so first thing, what comes to your mind is a compass, isn't it? So a compass has got its needle. You have a compass. You just held your compass in your hand, and you just the needle will point north and south. Okay. So you come to know where is north, where is south. So you have got even if you know where is north, you can easily find out other four directions. Okay. So you need to know only one direction at a time. Okay. So once you know where the north is, or east is, or west is, or south is, if you know only one of them, you can find out the rest. Okay. For example, if you know where is north, okay. So let's say I'm facing the camera right now, and that is my north. Let's say this is my north side. Okay. All I have to do is that facing north, I have to extend my hands. Okay. And my right hand is right now pointing to the east. If I'm facing the north, okay, my face is towards the north, then my right hand is going to point to the east, and my left hand is going to point to the west, and my back is pointing to the south. So simple. Okay, which you might have learned in school also. Okay. Now there is this little catch. Now this is a magnetic compass. Okay. Now this magnetic compass is slightly uh, having some problems to find out the exact north. Okay, I'll just show you in the next slide. See, in the next slide, if you see, I've shown you 2 points. One is the geographical North Pole, and there's a magnetic North Pole. Okay. Now, what is the difference between these two? Now, the geographical North Pole. the line which is going through which is going from center of the pole to the, which is coming out of at the bottom, geographical south pole. Okay. So these are the 2 points. These are the 2 points where the Earth is having Earth is pivoted. You can say that is the point where the Earth rotates. Okay, these are the physical points. Okay, so if you are standing exactly at that point, okay, uh, at that exact point, there is no rotation at that point. Okay, it is zero rotation. But that is a point which is that line which goes through these 2 points. That is the axis where the Earth is rotating about itself. Okay. But if you see, there is a red dot which is shown here as a magnetic north pole. Okay. So this is the line which is exactly at the south pole, north pole, and this line is going through the south pole and coming out here. But there is this red dot which is showing us magnetic north pole. Now, what is the magnetic north pole? Magnetic north pole is that this is where the compass is going to point. Okay. When you hold a compass in your hand, the compass is going to point to this pole, not this pole. Okay. So this is the pole which compass is going to use. Let's say, yeah. So this is my magnetic north pole, and this is the geographic north pole. So this magnetic north pole will be pointed by the compass. So it is not exactly the north pole, but you roughly know where north is. Okay. So there is a difference. This difference is actually, there's another big problem with this is that this particular magnetic north pole is moving. It is not static. It keeps on moving in different places. Okay. Right now it is moving towards Siberia. Okay. So it is not here. It has moved up till here maybe. Okay. So it keeps on moving because it is controlled by the core of Earth, the molten core of Earth. The Earth is having a molten core inside. It is made of iron. It's liquid iron inside. So as you know, if you have a bottle of water and you start rotating the water inside does not move at the same time. It takes time to it takes some time to move the water along with the bottle. So similarly, because the iron inside the Earth is molten, it is in liquid state. Okay. So this magnetic pole also keeps on moving because the magnetic pole is controlled by the iron core which is inside. Okay. So this is the compass is going to roughly point you to the North Pole. That's all we need for doing the normal astronomy. Okay, need not worry about that right now. Okay. Okay. In the next slide, there is a mechanism, okay, through which you can find directions using stars. But before that, before finding directions, you're supposed to know about the stars. Okay. So this is a rough documentation which is very popular. Actually, this is the Great Bear. Great Bear, which we see almost every night. You can see this. Okay, depending on the time and the day of the year. Basically, this keeps on moving. This keeps on moving around this pole star. Okay. So you can imagine the stars, they keep on moving like this, okay, around it. Okay. So this particular star, which is known as a pole star, okay, also known as the North Star. Okay. So it is there. So this star seems not to be moving because it is almost aligned with the currently aligned with the uh, geographical pole of Earth, geographical North Pole of Earth. Okay. So that's why we call it as a pole star. But after a few thousand years, this won't be our pole star because the Earth is also moving. So we'll be having some other star which will become our pole star. Okay. Okay. Coming to the other tricks, for these, you can, of course, use your phone for finding out your direction, because most of our phones nowadays has got a compass built in inside it. But if your phone dies and the battery is out, then what to do, isn't it? So there are a few other tricks like 2 stick and 1 star trick. There is a shadow trick. There is an analog watch trick, or simply even you can just ask a local person out there. You can ask somebody who, if you find, if you're near a village or something, because for a good sky, we normally tend to go outside, out of Mumbai, because Mumbai sky is very not good for, not very much good for astronomical purpose, and because of pollution, we have a lot of pollution. We have a lot of light pollution. We have got of dust and smoke pollutions. So you can hardly see very large amount of stars. Like one of your kids said that I've never seen a star. So try seeing a star tonight. Maybe because of this coronavirus, the pollution has gone a little bit down. So you might be able to see a few more stars in Mumbai sky nowadays, preferably from a terrace, because then you are above the street lights, so that you will able to see better. But if you are below, if you are watching from your porch, like from your garden or something, you may not be able to see much amount of stars. Okay, you might be able to see 1 or 2 very bright stars. Okay, okay, and then we have and many other techniques which you can use actually. So we'll go fast on this part. Okay, you can Google for all this if you want to find directions, and if you just Google for them, you'll find many other techniques also. Okay, so we are coming to the next part, which is our latitude and longitude. These are also are very important, because your location matters very much. Okay, so before you start looking into the sky, preferably you can find out your latitude and longitude. You can search for just Google for Mumbai latitude longitude, will come to know. Okay, so what is the latitude and what is the longitude? Okay, it's very simple. So you have a latitude which are these are latitudes, the lines which are going sorry, these are red lines which are going horizontally. Okay, these are latitudes. Okay, so you have got blue lines for the north hemisphere and the red lines for the uh, southern hemisphere. Okay, and in between there is the equator. These are imaginary lines. Okay, so as to we can divide this circle into parts. Okay, and these lines are in degrees, like you go from 0 degree to 90 degree. Okay, so you have this equator is at 0 degree and the poles are at 90 degrees. So this is plus, north is plus 90 degrees and south is negative 90 degrees. Similarly, there are longitudes, which are vertical lines connecting the poles. Okay, so there are half circles, you can say, which are of 180 degrees starting from 0. Okay, there is a prime meridian which goes from pole to pole, which goes over your uh, Greenwich Mean Time, if you know that term. Okay, so it goes over Greenwich in England, and that's how the universal time is maintained. And on the right hand side, we have the blue, that is the east word lines from 0 degree. And then we have the, on the west, we have the red lines, which are again going towards uh, western side of that's about 180 degrees. So both are of 180 degrees, so 360 degrees complicated like this. And here also we have 90 degrees this way and 90 degrees that way. So 180 degrees covered this way. Okay. So on this globe, where we are, that is very important. Like again, we are showing in another diagram, that where we are in 45 degree or in 10 degree or 20 degree. Like Mumbai, we are having a latitude of 19 degree. So we are close to equator. Okay. So that 19 degree is there. Okay. So we have uh, the latitude here is 19 degree approximately. Okay. And longitude, we are somewhere around Mumbai, somewhere around at 72 degree east longitude. Okay. So you have these two things. You know exactly, like in a graph paper, you have a cross in a graph paper where exact point you were. In a globe or in a circular object, we have latitudes going like in a graph horizontally and longitudes which are going vertically. Wherever these two meets is the point where you are standing is your latitude and longitude. In short, we call it as lat and long, which you can find out from your phone using GPS, okay, and Google Maps, which is very easy to find. You just say, where is my location? In Google Maps, you'll be able to find it. And it can even give you the latitude and longitude of the place. So why does it matter? I'm coming to that point. See, it matters because if you change your position on the globe, your sky changes. Whatever visible in the sky, that will change. Because like if you're looking, for example, if you have observed if you have gone to SL World or something, when you go high up in your ride, what happens? Your everything goes down, isn't it? Your vision changes, your perspective changes. Okay, like when you go up, everything feels that everything is smaller. Okay, when you come down, things become bigger again. So, like when you are in a very tall building, if you go to the top of the building and see down in the streets, you will see the people are very small. Okay, your perspective changed. Your object's size changes. Your uh, uh, things change. Your orientation changes. Basically, you can say. For example, if I'm standing like this, like I have the Earth is being tilted out here. Like I'm roughly standing over India. Okay. See for me, I'm standing vertical. But actually, if you see, you are not standing vertical, you are standing at your angle, whatever it is. It's gravity which is pulling you in that angle. Okay. That's why you feel that you are standing straight. Actually, you are standing in an angle. So this actually, if you rotate, this is your latitude. Actually, you are standing in this angle, let's say in the red angle. But you'll feel that you are standing vertical. So for you, because when you are standing, it is relative. This angle is relative. Okay. So this is not the actual angle you will see. You'll actually see this angle. Okay. You normally feel that you are standing vertical, not in 19 degrees. Okay. You are not tilted towards like 19 degrees like this. Okay. So for me, it is vertical right now. For you also, it is vertical. So whatever you see on the top is known as the zenith, as it is written out here. Okay. Then whatever you see at the edge, okay, like on the flat, on the edge, when you see when you go to the beach or to a river side or anything, where the sky seem to meet this is the sky and this is the sea, where there's a meeting point between these two. It doesn't actually meet, but it seems to meet there. That is known as the horizon. Okay, that is known as this horizon. This is the horizon. Yeah. So that these two point the horizon which you have to uh, uh, remember. So one is this is the observer who is seeing things. So observer sees this is the zenith and this is the horizon for him. So if I change my position, let's say if I go from here to here, then my horizon will change and my zenith will change. So the sky will change accordingly. The sky will seem to rotate. Okay. It doesn't rotate physically because I have moved into a different place. The sky will correspondingly move in a different direction. just like moving in a car. Okay. Or if you're going in a merry-go-round or something, as the merry-go-round rotates, your view changes, something like that. Very simple. Okay. Okay. Now we come to Earth's movements. So we have got basically 3 movements for Earth. Okay. I think two of the movements you very easily know. One is the rotation, one is the revolution. Third, you may not be knowing, but somebody might be knowing this particular phenomena, but this is very, uh, this is hardly uh, people know about this. Rotation and revolution is like, this is a daily thing. So what is rotation? Rotation is very simple. We all know it. It is like 24 hours day and night cycle. Okay. So we know all about it. And this is the fastest one, causes day and night. And to be exact, it is 23 hours and 56 minutes. It is not exactly 24 hours. It is 23 hours and 56 minutes. Okay. What happens to the rest of the 4 minutes? You can figure it out. Okay. Okay. Because you have this, you have seen these months are having 30 days, 31 days, isn't it? Has anybody asked this question? Why there is 31 days? Why there is 28 days? Why there is 30 days? You know, why not all the months are having 30 days to be simple, right? You may not be knowing that, but this answers that question. Okay, this 56 minutes, you have to compensate that for somewhere, right? Okay. So that 4 minutes needs to be adjusted somewhere. Okay. Okay, that's about rotation. You all know that very well. I'm not going to go again with day and night stuff. Okay, because it is every day. Then this also is revolution, which is 1 year. Okay, we have we are on roughly about this point right now, which is 22nd of June. Okay, yesterday it was 22nd. So today we are roughly around here. This is summer solstice, we call it as. Then we are going this way right now. This is the movement. Okay. And Earth is tilted at 23.5 degrees, which causes the seasons. These things also have been taught to you in the school. If you have not learned it yet, it will be taught to you in the school. Okay. So very simple things. Okay. Then September, then we have December 22nd, which will be winter solstice. Again, September is an autumnal equinox, where day and night becomes same. Okay, equal amount of day, you can say equal amount of daytime and equal amount of night time. But in the June, when you have the summer solstice, you have the maximum. Right nowadays, the daylight is maximum and the nights are very short, which will exactly happen opposite here in December, where the nights will be much longer than the days. And in the March, there's the vernal equinox, where you will have 21st of March, typically it is. You will have this equal day and night again. So these things are taught to you in school. What is not taught to you in school is this one. This is known as a precession. You might have seen this while playing. All of you might have played with a top. Okay. So when you spin a top, what happens is that initially it spins very fast and very nice. Okay. And after some time, the top starts, first of all, the top will stay straight like this. Okay, it will stay straight. Okay. And it will keep on spinning very vertically without any problem. As the speed reduces, the top starts doing this. Okay, you might have seen that. This movement is known as precession. Okay. And Earth also does this precession thing. Okay, because Earth is also like a spinning top. Okay. So it is also supposed to do this. Like here it is shown. The Earth, the top is moving in this direction. This is precession. Similarly, today the Earth is like this. which is pointing to the North Star nowadays, which is also known as the Polaris. Okay, and slowly it is doing this movement. Okay, so this whole one cycle, to complete one full rotation, it is going to take 26,000 years. Okay, this is the extremely slow one. So we cannot see in our lifetime it is going to move anywhere away from the North Star, because our life is only hardly 50, 60, 70, maybe 100 years. Okay, so you cannot see this kind of a movement out here. But Earth is constantly moving at a very, very, very slow pace, which is also known as the precession. This is mostly which is avoided in the school because it's a bit tricky to understand. But in college, when you reach colleges, you'll come to know about this. If you learn physics, these are the primary movements of because they will teach you the mathematics behind the precession and how a top spins, why it falls down, and all this stuff will come to in a mathematical way to you. Okay, so these are the three movements. Okay, so we have time for another short break, but we'll not take much of questions. You can grab a snack, okay, or you can just have some tea, coffee, anything you like. Okay, the session is almost I think we are almost halfway through. A few more slides are there, but you can take up some questions. Sure.
So I am having one question.
Yeah, please.
What if our compass does not work and we are lost in some place?
We'll not get lost in some place until unless it is totally dark and you can't see any light in the night.
Yeah, like the forest, some places.
Yeah, exactly. Just a minute. Actually, unfortunately, if you're in a forest where there are a lot of trees and you cannot get up onto a tree, it will be very hard for you to find the directions. And your compass is dead. Suppose the compass is broken, or maybe your phone is not working. Nothing is there. It's very hard. Then you have to wait till the morning. That is the only way. You have to wait till the morning to find out where the sun comes up, where the light is coming. See, if you wake up in the morning before the sun comes up, you can see a white glow. Have you seen that ever? Once you have seen. So like if you wake up in the morning by 5 o'clock or so, you will be able to see there is a white glow on some part of your horizon. That means the sun is coming up from that area. You'll see that white glow which is coming up, white or orangish glow. Okay, so you can see the sunrise. So if you are stuck up in such conditions where there is no other way, then you have to wait. You have to spend the night. Okay, stay safe from the animals and everything, and in the morning you'll be able to find out the direction. But in the night, if you can see a few stars, because there are about 26 bright stars in the sky which you can see easily with at any point of anywhere, from almost anywhere. Okay, even there is a lot of light pollution, still these stars are visible. All the 26 are not visible to us at the same moment because that is all over the globe, but at least few of them are visible. That's why we need this particular stuff.
Thank you.
Yeah. Anyone wants to ask any question?
So, how does a moon change its color?
Moon normally does not change color. I'll explain you. Have you seen the sunset?
Yeah.
So the sun, will you feel the sunset color?
It becomes orangish.
It becomes sun is very interesting. In the daytime, if you see the sun, it is white. Okay. the standard white color of the sun. Okay, or you can say yellow white. Okay, then in the evening when it drops down to the horizon, it starts becoming yellow, then it becomes orange, then it becomes very deep orange, and almost like goes to the red band before it sets. Okay, almost reddish. Okay, very very high tone of reddish and orange. So why this change of color? It is because of our atmosphere. Okay, because our atmosphere acts like a prism, and when light goes through the prism, it is the color band is separated. We always have this. Let me show you if I can, if it's possible. Uh, Sorry, just give me a moment. Just yeah, if you see the uh, just I've shown some images of prism. When the light goes through the prism like this, it separates into the multiple colors. Okay. So this is the job of a prism. Like in our case, what is happening is you have this prism in form of our atmosphere. It is the air around us. So we are at this end of the prism, and the light is coming from the sun as from this end. So in between, you can imagine there is a prism of air. Because of that, what happens? The light splits as it goes down, because this angle matters. As the angle changes, the whatever, suppose, because we are not going up and down, we are standing somewhere here. So when you are standing at a particular vantage point, the light will directly come through. Where you can see, like in the noon time, when the sun is above our head, the light is directly coming through. Okay, but as the sun sets, the light doesn't come through straight away. You can imagine that, because light is coming through the edge of the earth. It's not coming through like this. It is coming from the edge, like this. Okay. So
So the same way the rainbow also forms.
exactly the same. The rainbow is not formed because of the atmosphere. It is formed because of the water droplets. Okay. So there is a slightly different mechanism, but the the behavior of light is the same. It goes through the total normal reflection through the small rain droplets, and because of the angle, we see the rainbow. So, like there is a simple mechanism to view a rainbow. The sun has to be in the horizon somewhere low, and the rain should start. Then only there has to be a 90-degree angle approximately, so that you can see the rainbow. The sun has to be on your horizon, and the rain has to start from top. Then only you'll be able to see the rainbow. Fine. Okay. So we'll proceed to the next session. Okay.
Uh,
Yeah. Anything?
okay, nothing.
Okay, fine. So let's get to our tools now. because we have to wrap up fast. Another maybe few minutes, 45 minutes or so are left. So let's go to the tools part. So
Okay.
first thing is naked eyes. These are the today's session will be based on this. Okay,
Hmm.
our primary tool, because we have our eyes to help us see maximum amount of sky without any issues. If you are staying in a proper environment, unfortunately Mumbai does not give us proper environment, but naked eyes are the best. As we know, if you're lost in the dark, underneath the dark skies, you can at least look up and find out your directions. Okay, so these are the best tool. These are the best God-gifted tools we have to start with. Then we have binoculars. Have you ever seen a binocular? If you are not, if you're not seen, this is a pair of binoculars. Okay,
Your voice is breaking.
I think that it is a network issue.
Um,
Yes, sorry. I think his network is probably, playing up. Let's just wait for a couple of minutes. Yeah, he's disconnected, so he should join us back. And they usually have power cuts, so he did mention that there might be a possibility. So you can move around. You all have been listening very attentively and very patiently. So you can probably go drink some water, grab a bite till he joins us back. I'll call him and let me find out what the situation is. Yeah? We are here only. So yes, it's a network issue. He's just connecting. Should be with us in about 2-3 minutes. Okay.
okay. So sorry, there was a
Great.
slight glitch.
Welcome back. No problem. No problem.
Uh,
So it was a network issue.
yeah, network issue, little bit network issue. Yeah, it happens. So this is a binocular, as you see, okay, which is one of the tools you can use. But today we are not going to use any binoculars or anything. Okay, but we are going to have to go a little bit faster actually. Just let me share the screen again. Okay, so binoculars. Then we have planetarium software, which we are going to show you. Today we are going to use this. This will be our main topic of today's day. Okay, because we cannot go out so easily nowadays, so better use this software. Okay, initially, and then telescopes. As I have shown you my telescopes, these are the. This is a smaller one in size, of course, a bit taller than the other one. But this is the bigger one which I have. Okay, so these are two telescopes we have. Again, these things we are going to discuss later on in some other session, because they are big topics of so we'll go to optics, binoculars and telescopes later on. Today we'll be learning a little bit about naked eyes along with the planetarium software. That is what is the aim of this session. Okay, we can divide it into multiple sessions if you wish. Okay, you can request Ashita ma'am for that. Yeah. Uh, and radio telescopes. This is another kind of telescope which a lot of people use. I have never used one, but this is also a different kind of telescope. We'll discuss this in some other session again. Okay, when we'll be talking about telescopes and binoculars, I'll include this also in that session. Okay, so naked eyes. This will be our first thing. So naked eyes is naked eyes, just eyes, using your own eyes. What you can see with naked eyes. Using your eyes, you can see planets. If you know how to identify them, of course. Okay, because if you say planets, they also look like normal stars. Okay, then of course the bright stars which you see. Then we have these eclipses, which we had recently, two eclipses. One was a solar eclipse. Then we had a lunar eclipse. Okay, 21st was the solar eclipse, that is on day before yesterday. Okay, and then lunar eclipse was I think on no recently, on some, that was on August. Uh, yeah, it is on 5th. It was on 5th of this month itself. Okay, because they come in pairs. Okay. Then meteor showers, shooting stars that can be enjoyed with our naked eyes. Then you have got bright comets, which is a bit rare, but you guys will definitely see one. Okay, in your lifetime. Okay, these are bright comets. You'll able to see the Halley's comet, which will be coming, I think, in somewhere around 2040 or something.
Sir, 2061.
2061, right? Yeah, it comes after 76 years, if I'm not wrong. Yeah, 76 years. Well, that I had seen in 90s. I think it was in 94 or 95. I had seen that Halley's comet. Then again, it will come in 61. Yeah, good information. So you guys will definitely see that. And in between, if you're lucky enough, you might see some other bright comets. Okay, and artificial satellites also you can see in the evening and early morning times. The satellites, you can see small stars. They're moving pretty fast. Okay. Uh, I had posted one more event which was there, I think, on 21st. Yeah, 21st. That is on the 21st. Yeah, I think so. I had posted in Tribe itself regarding the International Space Station. You can see the International Space Station with your naked eyes. Okay, that's also very interesting to see. Okay, and there is something known as the iridium flare. It's a bit hard to understand what is the iridium flare, but someday we'll try to understand it again. Okay, so let's start with the starting things. What you can see right now. Okay, planets. We start with the planets. So what planets we see normally? Okay, so normally we see something known as evening stars just after the sundown. Just after the sundown, as
Sir,
the
it is called as Venus.
uh, yeah, it is one of our planets. We see two of the planets very easily. Okay, one is the Venus and one is the Mercury. Okay, so also known as evening stars. For example, there is first one is Mercury and second one is Venus. These are the two uh, planets actually we see after just after sundown, and because they're moving up and down, they're moving in circles around the sun. So sometimes the Mercury will be there, sometimes Venus will be there, sometimes both of them will be there, sometimes both of them may not be there. But
Sir, from 14 to 17 July, there was Jupiter, Venus, and Mercury.
exactly, that is because Jupiter was in conjunction. The Jupiter orbited to there in apparently to that place. Okay, so Jupiter was in the picture also. Okay, sometimes even Saturn also comes in. Saturn, Mercury, Venus, you can see. So there is combinations. These are known as conjunctions. When they apparently they come into view, but always it doesn't happen. So in between it happens sometimes. Okay, I'll show you some tricks how to find them. Okay, there are sites which can give you such informations. What you can see at what point of time. Okay, there are some very nice sites. Okay, then another planet you can see is Mars. Okay, which is red in color typically because the Mars looks red. It has got red soil all over, so it requires. It has been seen as a reddish planet.
Sir, it looks like a red giant.
Yeah, it looks like a red star, you can say, or a red giant. Red giant also looks like the same way, but it doesn't twinkle. The one major thing is that all the planets don't twinkle. Only stars twinkle. That is the main difference. Okay, if you see the planets, they will never twinkle. Like Mars and Jupiter, they will be static. They will not blink. In Mumbai skies, they will all blink, but if you go to some cleaner sky, they will not blink. Okay, you can see Mars, you can see Jupiter, you can even see Saturn with your naked eye. You don't have to use anything. But Saturn, you will not able to see the rings, but it will come as a dot. You see it as a dot. Okay, just like any other star. So these are the things in planets. Then we have bright stars. The sky has only 26 bright stars that can be seen from Earth. So if you just Google for it, you will find a full list of stars and the names and their exact coordinates and everything. The full details you'll be able to find it. Okay, I'll not go through all the star names because it will be a total waste of time. Okay, they are also known as guide stars. Okay, now guide stars means what? They normally able to guide us. Okay, if you have those stars, they normally able to guide us through the entire sky. You can say these are the landmarks. Okay, like buildings we have. Okay, here is the building, there is another building, that kind of thing. Okay. Then we have eclipses. Of course, there are solar eclipse. There are three types of solar eclipses. One is a total solar eclipse, one is the annular solar eclipse, and there is a partial solar eclipse. Okay. One we experienced day before yesterday in Mumbai was a partial solar eclipse, but in some parts of India, people have got to see an annular solar eclipse, which looks like a ring. I'll show you some photographs which I have clicked. Okay. And there is a total solar eclipse, which also I have clicked one. Okay. Way back in 2009, I had been to China for chasing the eclipse. Okay. It's pretty interesting out there.
Sir, we can see the ring of fire.
Yeah, you can see the ring of fire. We actually saw one and we clicked also. I'll show you the photograph. Yeah. And then in there we have this lunar eclipse. We have got total lunar eclipse, and then there is a partial eclipse. Then there's a in partial also there are two kinds of, one is umbral and penumbral eclipse. So those also I'll show you. Few snaps will come to know. It's hard to explain it. Okay.
Sir, actually, penumbra are the two parts of the landscape of Earth.
No, actually, it is a part. These are two shadows. See, this particular image I'm showing you right now has got two shadows. Okay, you might have seen if you are standing below a tube light or something. Okay, you might have seen that you get uh, like sometimes you get a fuzzy shadow around your main shadow. Have you seen that?
Yeah, I have.
You have seen that, right? So now, if you see this in this, this is the moon. Okay, this is what is a solar eclipse. Okay, this is what happened on 21st recently. Okay, so moon came in between Earth and Sun. So the moon casted a shadow. Nothing happens. The shadow is just a shadow. Nothing happens. Nothing physical happens to either of the moon or Earth. Only the tides may become a bit higher because both the sun and moon are pulling the water out of, trying to pull the water out of Earth. The tides will a little bit go higher that day. That's all. Nothing physical happens to the Earth or moon or sun or anything. Okay. But the
Sir,
shadow, if you see, yeah.
I have heard that there is one more shadow, Antumbra. Antumbra.
Antumbra you cannot see on Earth because that is a very difficult thing to see because that is reflected shadow from Earth and coming back again. It's very hard to see. It's a reflected thing. Okay, so it cannot be seen. You can measure it by some astronomical instruments maybe, but it's very hard to see that kind of a thing. But I have not seen that, or I have not experienced that ever. Okay. So basically, umbra and penumbra is that what you can experience pretty easily. So umbra means the core shadow. Okay, the core shadow is here, and then we have this, two different rays coming in around the core shadow. If you can see, if you trace out the lines from these two, okay, some of the light leaks from the other side. Like this is casting the main shadow, but there is light leaking from this side also. So the shadow becomes a little bit less darker, which is known as a penumbral shadow. Okay. So this thing happens because of the light is leaking because the moon is very small. So there is a leakage of light in this area. So this area you will find as a little bit less darker, and this is known as the penumbral shadow. The umbral shadow and penumbral shadow. This happens in both the Earth will also do the similar kind of a phenomenon, and same the moon will also cause the same thing. Okay. Now, this is a very important warning for you everyone that do not watch the sun without solar goggles. Okay, never watch the sun. Okay, you might go blind, and probably you will go blind. Okay, which had happened in 2009 to many people in India and abroad also. They were trying to watch the sun through a telescope without using any protection. They immediately went blind. Okay, so this is very important. So what is the solar goggle?
Sir,
Yeah.
I was telling that not only on solar eclipse, on any day, you should not see the sun for too long. Like you can see the sun, but don't see it for too long. Otherwise, your eyes will.
Yeah, actually, best way to watch, if you don't have a solar goggle, you can watch the reflection of sun on water. You can,
Yeah, we can do that too.
yeah, you can use a tub of water or a bucket of water, and you can see the reflection of sun using a pair of goggles, normal goggles. You don't have to use any special goggles for that. You can use just a pair of sunglasses, which is normal sunglasses, and look into the water. Don't look directly into the sun because the sun is going to give you a lot of UV rays, which can damage your eyes. Okay. And also it is very bright. So if you look into the water, it's not that bright. Okay. Okay, this is a solar eclipse which I had gone to China in a place called Hangzhou in year 2009, in same month, you can say June, July, okay, 22nd of July. But right now it is 1 month ahead, so it was there in 2009. So you can see the ring of fire out here. This is a ring of fire. You can see red spots. These are actually clicked from a camera, which we could find out there. Okay, and this is the total eclipse, and this is also known as a diamond ring. Okay, and if you see an eclipse like this or this, these are partial eclipses. Okay, this is what happens when you see a total eclipse. Okay, this is the ring of fire when you see the totality. Okay, and this is the diamond ring when just the sun comes out of that at the edge of the moon. You can see it's like a diamond ring. Okay, it glows very nicely, and you can see as if there is a diamond out here. Okay. This is the annular solar eclipse, which I had gone in 2010 to Kanyakumari in India. And using my bigger telescope, I had shot this. The other one also I had shot using a bigger telescope. Okay. You can see this ring. Okay, this is the annular eclipse. You will not see the ring of fire. You can see just the ring, as if it's just a ring. Okay, here the moon is smaller than the sun. In the total eclipse, the ring is bigger. Okay, the moon is bigger, so the moon completely covers the sun. Okay. Then this is the partial solar eclipse, which was recently in last year, 26th of December, 2019. We saw this from our terrace, which was visible from Mumbai itself. So we saw this eclipse. This was also fun. And this is me and my friends and family. Okay, and the terrace, and we are watching the eclipse with a big telescope, and we shot the whole thing. Okay. And of course, we can see the artificial satellites, the ISS. You can see artificial satellite going like this on the sky. Of course, this is a trail. You will see only a star moving like that. And this is the iridium flare, as if it is a spark in the sky. Okay. Then you'll have this lunar eclipse. With the same phenomenon that happens, umbra and penumbra. Okay, our Earth will cast a bigger shadow because the Earth is much bigger. So moon typically goes through penumbra and umbral eclipse. Recently, we had a penumbral eclipse on, as if the date I had told earlier. I think around 5th or 6th, somewhere at that time. Moon was out of this. It was in this shadow, not in the umbral shadow. Okay. So a total lunar eclipse normally looks like this. Okay. This again I had shot in 2011 from Goregaon, if I'm not wrong. Yeah, Goregaon, exactly. Observed from Mumbai again. And this is how the moon looks in totality. It looks like a copper moon. Very beautiful to look at. And especially if you are using a telescope, it's even beautiful. Then this is lunar eclipse. This is umbral. Partially, of course, partial lunar eclipse is umbral. The top corner is gone, if you can see. Okay, again shot from Mumbai itself. Meteor showers, shooting stars, which you see normally, which you can observe. Okay, there are many actually. I'll give you a list. Okay, so how to watch meteor shower? You just go to some location where there is no light pollution as such, like marshes or some nice place. Like even you can go to some open space nearby where there's a little bit of light pollution is less. Okay. So these are some active, uh, I can say these are the, what do you call this? Meteor showers you can see from these dates. Okay. These dates you will be able to find from Google itself. If you just search for meteor showers, these dates you will be able to find. Okay, very easy to find these dates. And
Sir,
yeah,
my father's birthday is on December 28th and my birthday is on December 5th. So December 4th, after that there's December 5th and one of them is December 28th.
okay.
So
So typically, this is the most beautiful time of the year. December is the most beautiful time.
yeah. And I was born also, like I was born on December 5th.
Yeah,
And my friend was born on December 3rd.
yeah,
So
that's great, na?
we are really close. We are like twins, almost like twins.
Yes, yes. And see, uh, the date which I am talking about is nearly about 13th or 14th of December. You should go to the terrace and sleep just like this, you know, just like this, as I've shown you in this thing. You have to sleep on take a mat or something and sleep on that. And if you just keep on seeing the sky, you will see lots of shooting stars. Okay,
Yeah, yeah.
that when you come close to the December, that date, you just Google for the shower, Geminids it is known as. Okay, so this Gemini shower is most beautiful of all of them.
Yeah, cool.
Even you can use see this one also, but this is the best one. Okay,
Even in which my birthday is
yeah.
there. Haha.
And see, these are the sites where you can see the
Can you wait? I've got my phone. I'll just check.
you can take a screenshot of this. Fine, if you want, you can take a screenshot. I'll post it later on onto the.
Okay, so should I show you? I've got my phone. I'll just show you. 1 minute.
Okay. I can't see anything. It's totally white. Okay. You are trying to show me that. Okay, dates you are trying to show me.
It's written find the best time for web meeting planner, or use the time and date converters. Online. Blah, blah, blah. Yeah, down it's written sun, moon, calendar 2020, eclipses, time zones and calculators, the world clock, meeting planner, more blah.
Yes, yes, yes. Good, you found it. See, this is how a comets look. Okay, comets are small things and they are irregularly shaped bodies, as I told you earlier. Okay, so you can find the definition, and there are a lot of comets in the sky right now also. Okay, their size is like 750 meters. Small comets are like this size, and sometimes they are very big, like 20 kilometers big boulders which are coming in. Okay, and this is one of the comets I shot in this particular date from Juhu Beach in Mumbai. Okay, so that was in 2013. So this was a comet, very hard to shoot. I had gone there for 3 days to find this comet. I couldn't get it. On the 12th I could find it and I shot it. Okay. And of course, you can use binoculars with a stand. This is actually a binocular with a stand. If you see that. Okay, this is actually a binocular, not a telescope. It's with a stand. Okay. This is another warning for you that never point binoculars to the sun. You will go blind. Okay, don't damage your eyes. It's very important. Exactly, exactly. Those are comets. Yeah, yeah. Okay, now there is a small object which we see. Okay, I'll come to that. Okay. Uh, through binoculars, you can see these kind of small things. You can see star clusters, global clusters, bright comets. Okay, and galaxies like Andromeda. But there's the only, I think, the Andromeda galaxy is the only galaxy you might able to see with binoculars in a very good sky. You cannot see it like, every time. Okay. Okay, I've spoken uh, a lot. Okay. So I got very little time left. I think only 5 to 10 minutes left. Ashita, can we increase the time a little bit?
Yes, yes, yes. Please go ahead with the question answers round. It's okay.
Yeah.
Carry on.
Fine. Because you can just grab a drink and I'll just change the mode to planetarium. We should go start with the planetarium software right now. Okay. Okay. So okay. So what is the planetarium software? The planetarium software allows you to uh, basically go through the sky without actually getting out of your room. That is what a planetarium software is. Okay. So the software I am going to use here is this. You can make a note down of this. It is Stellarium. It is known as Stellarium. Okay. So you can find this software in this website called www.stellarium.org. Okay. So I'm right now in that site. This is how the site will look. So actually there are two versions of this. One is a web version. If you see this on the this thing on the right out here, let me try to.
What is the, what do we have to type?
Stellarium. You want to see?
I mean, www.stellarium.org. Yeah.
Yeah. Can you see that now? This is the name.
Got it.
Got it, right? Okay.
Just a way.
Okay. Now you can use this Stellarium web. You can start with this icon right here. Okay. You can start with this icon, or you can download your Windows version from here. Okay. From these 2 points. Okay. If you are having Windows PC, you can download from here. If you are using an uh, Apple iPad or something, you can use it from here. If you are using Linux, everything. So all the softwares are here. And if I go there, just a moment.
Sorry.
If I go here, okay, this is how the.
So the link is www. What is the link? Can you just again say?
Stellarium.org.
It's typed in the chat box. Shaunak has typed it for all of us. Yeah, just check it.
Okay. See, this is how it will look. Okay. So in this, you have got to set few things. Okay, let me come back with annotation. Let me stop the annotation. Just agree to it. And typically, it will ask for the for your location, which is automatically chosen by the software. Right now, I am from Vasai, so it has chosen. If you see the bottom left corner, somewhere it is shown as Vasai Virar. So it will automatically come to this screen, and it will automatically show you this screen. Okay. Now, in the screen, you'll see the current sky view, okay, which I have kept right now as 8 o'clock in the evening. Okay, if you come to the normal uh, real time, right now it is not even sundown. Right, this is the western sky which is there. Just sundown is going to happen. So you can already see the moon, which is supposed to be here. If you can see it faintly, it is here, the moon.
So it looks very white.
Yeah, very white. Okay, because it is not yet sundown. The moon is somewhere here. Okay, so we are looking into the western sky. Can you see there's W here? This is the western sky. Okay, so this is the W, and this is the northern sky, and this is the eastern sky right now. But I can change the time. I can change the time. Like say, okay, let's make it 7:30. Okay, and now see the sun is now the screen has become yellowish. Okay, now let's make it 8:30. Now see suddenly the stars have started to come in. Okay, so you can actually uh, uh, change the time out here and get your star at any point of the day. Even in the daytime, you'll be able to see the stars and everything.
Sir, can you repeat the site?
You want me to repeat the site?
It's in the chat box.
It's on the chat box.
Stellarium.org. It's written in the chat box. Shaunak has typed it for us. Just check, please.
Okay. So once you have your location fixed, okay, this is the Vasai Virar, India. It will be shown in a map like this. Okay. You can use the auto location feature. It will automatically find your location. If not, you can select your location using the map where you are, because that is very important, as I have told you earlier. Else your sky view will not be correct. Whatever sky actually you'll be viewing from your terrace will not be correct, will not be matching to this particular software. Okay. So
when I opened this, I could see everything, whatever you were showing, presenting.
pardon? No, you cannot see everything. Definitely not. Okay. Right now, because I have not put the this is not the full software. This is just an elementary software which is without downloading anything. You can see this. Okay. I'll just show you the full software where you can even turn right now. Let's see. Let's turn off the atmosphere. Can you see the sky has become darker? Can you see the change? The sky becomes darker. You can even turn off the land. You can turn off the earth beneath you. See? Now watch whatever is below the horizon also you can see. Okay. Actually, this is the earth. Okay. Earth was here. But I can remove the earth if I want to see. Now if you go here and see, the sun is below us. Actually, you can see the sun here. But it has already set. It has gone down. Okay. So it is below the earth. It is already set. Okay. And then you can put the atmosphere on. Okay. And because we are in Mumbai, actually you cannot see such great amount of stars. I'll speed up for you a little bit. I'll go back in time. So actually in Mumbai, you'll be able to only see some stars like this. Or even less. Maybe even less, like this. Only a few stars. If you watch the sky in the night, you'll only able to see few stars. But if you go further, okay, if you go away from Mumbai, okay, you'll able to see maybe stars like this, okay, somewhat like this, but little bit lesser in if it's not even dark, not very dark sky. So if you want to really find very dark spots on the face of Earth, then you have to go to specific places far away from Mumbai. Like we travel 200, 300, 700, 800, 1,000 kilometers also to find very dark skies where you want to do things. Okay. So this is the web version of the software. I'll just show you the actual version of the software which uh, I've kept ready for you.
Kanish, do you have a question? Okay, he has his hand raised, so I was wondering if he has a question or something.
Okay.
Probably he's giving you a high five. He likes it, so.
Okay. Coming back to the actual software which I have downloaded, installed in my PC, and this is the actual software. Here you will have a lot more many controls than the previous one, because here I can accelerate the time. If you see below at the bottom of the screen, there is a time accelerator, and I can accelerate the time.
Sir, can you tell the name of this
Actual app, you mean to say?
the this one which you are showing right now?
It's the same software, same Stellarium software.
Okay.
Okay, it's the same thing. Okay. So I can move back and forth. Like, see, I can move the sky this way or the other way. Okay, I can stop the sky. I can play it. I can stop it. I can do whatever I want. Okay, I can go back and forth in time. Like, see, I can accelerate. Okay, I'm in accelerated mode right now. So time is moving very fast. Okay, can you see the sky rotating? Can you see it?
Yes, we could see the moving sky.
Yeah, this is what it is. You can see the sky rotating, and if you observe very carefully, there is this center star is not moving much, isn't it? This particular star is our North Star. Okay, everything else seems to move around that star. Okay.
Sir, because North Star never changes its place.
Actually, yeah, you can say that. Apparently, it never changes its place. Okay, it is apparent. It is not physically. Actually, this movement is because we are moving in that direction. We are moving from west to east. That's why the stars are moving from east to west. Okay. So this is the apparent view. I'm going backwards now. Okay. Fine. So this is how you can control it. Now, I'll just quickly show you a few things. First of all, there are some grids which helps us to understand the positions. So, sorry, I'll just turn on the equatorial grid. Now, when you see the grid, can you see the grid on the screen? Okay, this grid, if you see closely, the center is very close to the pole star. Okay, which is actually it is 1 degree away from pole star, because we are in the precession movement, so we are having this particular thing. Okay, so there is a grid you can turn on. It helps you easily locate things around. Okay, so you can turn it off again. Now let's see some of the constellation lines. If you connect the stars, how they look. See, now you can see some constellation lines. These are imaginary lines created by our ancestors. Okay, and imagine some figures around them. Okay, so right now they are lines, but I can turn on some figures, constellation art. Okay, people imagine these kind of arts around them. Can you see them? There are so many. Okay, even there is a peacock. If you see this, and if you want to see the names, what are these? Then you can just click on the names, and it will show you the names of these constellations. Okay, like Draco is one of them. Okay, this is Ursa Minor. Then there's somewhere it will be the Ursa Major. Okay, I'll get you the Ursa Major. Okay, That is one of the prime thing what we try to see every night. Okay. You can see this Ursa Major thing out here. Okay.
Sir, can you find Hercules?
Yeah, you can find Hercules. See, Hercules is here. Yeah, Hercules will be typically almost visible. Hercules cluster.
Sir, can you find Hydra?
Yeah, you can find Hydra also. Okay. Now let me explain a simple thing. Okay. So this is my Ursa Major. Can you see these two stars here? Ursa Major.
Yes, sir.
This particular. I'll just come up with the. Just a minute. Sorry. Yeah. This particular star. Okay. Actually, there will be stars everywhere. That's why I'm trying
Uh,
to click on them.
Kaushik,
Yeah.
I'm getting this blur. I mean, the words are not proper. I mean, it's coming. I can't read fully.
Hey, you're on a mobile phone or something?
No, I'm on my laptop.
Uh, I think you need to
Yeah, I'll check my internet connection.
check your internet.
Yeah.
Okay. Now let's see. This is if you see these two stars out here. Okay, and this is our pole star. Okay. Now if you connect them, okay, if you connect these two stars, it will always point to the pole star. Okay. So this is very interesting, which we see. And now this is known as the Great Bear. Okay, these seven stars. Okay, this is what we always figure out we try to figure out in the sky. This constellation, this is the part of the Ursa Major constellation. And when you connect these two stars like this with a straight line, you will always find this star, which is your North Star. That's how you come to know where you are and how to find the North Star. This is a very easily seen constellation. At any time of the year, most of the time this constellation is visible. So in your entire night, it will be definitely visible because this keeps on rotating throughout the sky. Okay. So right now, the time is set to, let's say it is 9 o'clock in the evening. Okay. You'll be able to see it in this position tonight also. Okay. So this is very easy. You can play around with this software and it helps, it will help you to find out the stars very easily. And first of all, you play out with this software without any complications. Don't switch on many things. Just turn on the star and try to go through the basic things. Okay. If you understand the basics well, you will come to know the other things also very easily. Not a very hard software to understand. Also, you do is first you try with the web version. Don't download the software initially because it has got too many settings to understand. Okay, like you might get confused. So I recommend that you go to your web browser. Okay, and I think I have to erase the annotation. Okay. you start with this particular version of the software, which is the basic. Okay, it will also show you the constellations. Okay, it will also show you the constellation art, no problem. Show you the grids. Okay, the fundamentals, you start with this particular web application, and later on when you are familiar with the full thing, then you can download the main software and you can use it. This particular software is available in mobile phone also if you want to use the mobile phone, but that is a paid software in that case. You have to pay for this software, but the web version and the PC version is free of cost. So better learn it with free of cost. Then later on you might be able to buy the software if you are really interested in that. Okay, they are offering it in mobile app also. Okay, so any questions? So after this, you can just ask me. I'll stop the screen share in that case.
Sir, I want to ask you something.
Yeah, please.
Sir, we are interested in buying a telescope for our home use. So, can you tell us what brand or how do we select one?
Yes, we can tell you, but the thing is that primarily you have just started with astronomy, or you're familiar with astronomy?
No, I just started with it.
Just started with it. My recommendation, sorry, just a minute. I'll just stop the screen share. Uh, my recommendation is that if you are starting with astronomy right now, uh, don't buy a telescope initially.
Okay.
Okay. Yeah, if you are just interested to having fun with telescope, you can go for it. I can guide you, no problem. The one I can show you right here. This one. This telescope is I had bought about 7 to 8 years back.
Okay.
This telescope had cost you around 10 to 12,000 rupees. You can contact me personally. I can give you the website and I can give you the addresses where you can buy it from. Okay.
Okay, sir. I have your mail ID is written on one of the screens I had seen. I'll mail you and get in touch with you over that.
Yeah, no problem, no problem. You can mail me. You can take the number from Ashita herself, and you can contact me also in WhatsApp. No problem. Okay.
Okay, sir. I'll try to get in touch
Uh,
with her.
yeah, this is a fun telescope. Yeah, you can use this, but again, highly recommended that never point the telescope to the sun directly. That's the most primary warning I every time somebody wants to buy a telescope, I give it, because it's very dangerous to use a telescope in the daytime. Okay, we use telescopes in the daytime also. Just in one of the slides, I have shown you the telescope is covered with a filter. It's a solar filter in front of the telescope. Okay, so that can be actually put over the sun, over the telescope, and then can be used. But without filter, it is never. Actually, I
No,
never.
it is more to view, more for the night sky and to see the occasional planets and all, which we sometimes can see, to see them
Yeah,
more clearly and all.
yeah, you can do that, but these kind of telescope will not give you that much of satisfaction to see, because that planets require a higher magnification.
Okay.
Okay, the magnification required is higher, but these
Okay.
are like cheap telescopes, so 10, 12,000 rupees telescopes. It, money is secondary, but the thing is that the quality of the telescope is also not very high. But
Okay.
you can enjoy. You can see the, if you put this telescope onto your uh, onto the sky, point towards the sky, you'll able to see the ring, Saturn ring, but in a very small form.
Okay.
You cannot expect it to see like very big rings and all that. Okay. So it is very important to understand that part. So
Thank you, sir. I'll take your number and contact you personally again because I need more details.
no problem, no problem, absolutely no problem. You can
Thank you so
contact.
much.
Yeah.
Sir, what is your number? Can
Uh,
you just type on chat?
yeah.
So like maybe I'll save your number or something.
Just a moment. I have put it in chat directly.
What? You're writing on chat.
I'll just put it. Yeah.
तुमने लाइट लगा
Okay. Shaunak made a telescope, right? It's good. We also make telescopes.
9, 8, 6, 9.
You can buy those telescopes. Right now, I have shown you two bought ones, two telescopes which I have bought. But whenever we are in the session of telescopes, maybe I will able to show you telescopes which I have made. I have made many telescopes. But the thing is that right now I can't show you because it's not with me right now. It is in my friend's place, so it's hard to access right now. And right now, currently we are building a much bigger telescope, which mostly nobody has uh, made in India. It's a purely handmade telescope. So we have been working on it for almost 2 years now, but we are making one. Hopefully, it will be we'll able to use it by next year or so because this year is gone, so season is gone, so we can't use it.
Kaushik, is there any, either Facebook page or Instas where they can follow you or connect with you also?
Uh,
And look,
I have my Facebook page, but I'm very bad in using Facebook. I hardly go there.
okay, okay,
But if they want to talk to me, they can talk to me in WhatsApp. I am active in WhatsApp.
okay,
Any
sure.
any questions they want to ask me, just all of you can contact me. No problem.
Great, great, great.
Just mention the context where you are that you are from that Zoom session that you are contacting me.
Yeah, just
I
you
can,
can
I can
probably
follow.
give the reference
Yeah.
of the tribe or Rasmakam session,
Yes.
and then he'll know how, where you get in touch with him. Yeah. Do we have any more questions for him right now?
No, thank you so much.
Okay, great.
Kaushik,
Yeah.
there is actually a app, Star Walk 2. It's really cool in that it shows the stars and all that. I installed that.
Yeah, yeah. There are actually many apps. There are actually many apps.
I checked apps of planets. So there were thousands. Like I just thought, Star Walk, let's see. So I just And I'll tell you, if you install it now, you can uninstall it also. If you go back,
You can
it
uninstall,
will
you can
give
install. Yeah. There are many apps.
get uninstalled.
I've shown you only one app because if I show you many apps, you'll be confused. That's why I've shown you one app,
Yeah.
February app, and it's a very good app which I have tried and tested over a lot of period of time. See, I learned planetarium software using this Telerium itself. Okay, and I found it very useful, and I have been using it almost for past 10 years now. Okay, it's a beautiful app, and it's free of cost, so it's very interesting.
Kaushik will just show you 1 minute.
I know 2, 3 apps. Can I just say the names?
Yes.
One is Star Chart, then Night Sky Lights.
There is a Google Sky Map. There are sky charts. There is a app. If you just search
Sky Safari.
Sky Safari Pro and all those things, there are a lot of paid apps. There are a lot of free apps. You can try any apps in mobile, no problem. But the thing is that first of all, you have to uh, just go out and see the sky at least for once. Okay, do that. Okay, try to go as high as possible. Try to go to your terrace of your building, or try to go a little bit further away from the street lights. Okay, like if you have a field or a garden nearby, try to go there and see the sky. It will help you a lot to understand. Like, try to find the pole star first, if you can see it. And if you can't see the pole star, then try to see this Arsha major thing. There are 7 stars, or also known as Saptarishi Mandal in Hindi. Okay, so it is there. It's seven stars. Okay, there are a lot of names for that. So you can those are the guiding stars. So if you can find those stars, you'll able to find it much better.
Great. So yes, thank you so much, Kaushik. It was a lovely, lovely, lovely evening and very informative. And thank you, audience. You've been absolutely wonderful. I mean, listening patiently, asking your questions. So it's been a really good session. Thank you so much. And yes, now you have Sir's number and you can connect with him. I think it'll be a good idea that you can make a group, whosoever is interested, and then keep on.
You can put me also in the group. We can discuss. No problem.
Yes. So Kaushik, uncle can make a group, or anybody interested, you can just WhatsApp him, and you can keep asking him, troubling him with your questions, and I think he'll be more than happy to just stay connected, right? And I think now his daughter wants a bit of his daddy, her daddy. So yeah. So thank you all, and we'll surely come back with more interesting sessions for all of us. Yeah. Thank you so much, Tiara, for being so patient. Thank you, Kaushik. Thank you.
Bye.
Thank you all. Bye-bye. Have a lovely evening. Take care.
Bye, sir.
Bye. See you.
Bye, sir and ma'am.
Bye-bye.
Bye. Bye-bye.